Welcome to Penrose Learning, where we make understanding easy.
You begin by naming the input and the unit of work you will count. This anchors every step. Once done, pick the computation model, RAM for uniform cost operations or comparison-based when comparisons dominate. Make sure to decide whether you analyze worst case, average case, or best case up front because your counting strategy changes. Then outline the main loops and recursive calls you see. This first pass gives you the concrete structure you will translate into a recurrence or loop cost next. You now convert code structure into math. Write loop costs as sums and recursive splits as recurrences. Once that representation exists, identify growth of each term, keep the dominant term, and discard constants and lower-order terms to focus on asymptotic behavior. Then choose a solving method, iteration for simple loops, substitution for tailored recurrences, or the master theorem for standard divide-and-conquer patterns. Make sure to justify each simplification so the final bound stands up to scrutiny. You finish by validating. Test small and edge inputs and compare actual runtimes to your predicted growth. This exposes model mismatches. Once validated, run empirical experiments scaling n to confirm asymptotic trends and make sure to account for constant factors if performance matters. If results diverge, check your cost model, hidden operations like memory access or amortized behavior. These are common culprits. Finally, document assumptions and the final complexity bound so others can reproduce and critique your analysis.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.